Hey there folks! This video tutorial will help you solve basic equations involving derivatives. Solving complex function of derivatives, as well as application of it in real-life problems will also be included. First, what is derivative? If read from a dictionary, it is something based on another source. In mathematics, it is a way to show the rate of change, that is, the amount by which a function is changing at one given point. The derivative is often written using dy over dx, meaning the difference in y divided by the difference in x. The d's are not variable and therefore cannot be cancelled out. The derivative of y with respect to x is defined as the change in y over the change in x, as the distance between x sub 0 and x sub 1 becomes infinitely small. In mathematical terms, the prime of a is equal to the limit of h approaching 0, f multiplied by plus h in the open close parenthesis minus f multiplied by a over h.
There are several rules in solving equations involving derivatives. The constant rule, constant times a function, product, quotient and chain rule, as well as implicit differentiation. The basic rule of derivatives is the constant rule. It's pretty simple. Whereas for any number c, if f of x is equals to c, then the prime of x is equals to 0. For example, f of x is equals to 5, then x is equals to 0. The power rule involves coefficients and their exponents. To find the derivative of such function, simply bring down the power in front of the coefficient and reduce the exponent by 1. For example, f of x is equals to x raised to negative 2. Bring down 2 in front of x, then subtract 1 from negative 2, making it negative 3. Hence, the prime of x is equals to negative 2x raised to negative 3. For example, 4x is raised to negative 2, wherein 4x is the coefficient of the function. First, you have to bring down negative 2 and multiply it by 4. Then reduce negative 2 by 1. Negative 2 multiplied by 4x raised to negative 3 is equal to negative 8x raised to negative 3.
The special case of a product rule is the constant multiple rule, which states if c is a number and f of x is a differentiable function, then cf of x is also differentiable. Getting the product of derivatives will be easier by following this rule, where f of x is equals to g of x multiplied by k of x. Getting the prime of f of x will be equal to g of x multiplied by the prime of k of x plus k of x multiplied by the prime of g of x. Example: the quantity of 3 of x plus 1 multiplied by the quantity of 2x squared. Write down the equation 3x plus 1 as it is, and then derive 2x squared. By knowing the constant multiple rule, the quantity of 3 of x plus 1 multiplied by 4 of x will be the answer. On the second term of the equation separated by the operation of plus sign, write down 2x squared as it is and derive 3x plus 1. Applying power rule on 3x, where x has an exponent of 1 that was brought down to multiply 3, and reduce itself making it x to the 0th power. You do know that for every number raised to 0, same goes for the value of x is equal to 1. Then make use of the constant rule, making 1 to 0. Hence, the answer is 2x squared multiplied by 3. Now, perform the solution and combine like terms. The same goes for solving easily the quotient rule. In order to get the derivative of f of x is equal to g of x over k of x, perform the rule whereas the prime of f of x is equal to k of x multiplied with the prime of g of x minus g of x multiplied with the prime of k of x over k of x squared. Differentiate f of x is equals to 3 of x plus 9 over 2 minus x. Apply constant times multiple function and constant rule. 2 is a constant and x raised to 0 is 1. Distribute 3 to the quantity of 2 minus x, making it 6 minus 3x minus negative 3x minus 9 over the quantity of 2 minus x squared. Now, solving the function. 6 minus 3x plus 3x plus 9 over the quantity of cancel 3x, leaving 6 plus 9 is equals to 15. Then write the denominator the quantity 2 minus x squared.
Chain rule is a formula for computing the derivative of the composition of two or more functions. That is, if f and g are functions, then the chain rule expresses the derivative of their composition. One can write to express the variables as f of x is equal to x raised to n. Then the prime of x is equal to n multiplied by x raised to the exponent n reduced by 1 times the prime of x. First, differentiate the outer function, which is x squared. Keep 3 times plus 1 in the equation and ignore it for now. Bring down the exponent 2 in front of the function and reduce the exponent itself by 1. Second, differentiate the inner function 3 times plus 1, 2x plus 1 is equal to 3 by the application of constant and constant times a function rule. Two times the quantity of 3x plus 1 multiplied by 3 is equal to 6 times the quantity of 3x plus 1 is equals to 18x plus 6. Simplify the answer as much as possible.
In implicit differentiation, it allows you to find the derivative of y with respect to x without having to solve the given equation for y. The chain rule must be used whenever the function y is being differentiated because of our assumption that y may be expressed as a function of x. For example, 2xy plus 5y squared is equal to 5. First, differentiate the first term 2xy into 2x and y, and use the product rule. Second, differentiate the second term 5y squared. Now solve for both terms. Transpose 2y and factor out dy over dx. You have to cancel 3x plus 10y in order to leave the function dy over dx by dividing both sides by 3x plus 10.
Here is a sample problem for implicit differentiation. Let's see. A woman 5 feet tall walks at a rate of 6 feet per second away from a lamppost. When the woman is 6 feet from the lamppost, her shadow is 8 feet tall. At what rate is the length of her shadow changing when she is 12 feet from the lamppost? At what rate is the tip of her shadow changing when she is 12 feet from the lamppost? Now, we illustrate a picture from the given problem. Remember that the woman's shadow is on the ground in front of her. We'll use y for this distance. The distance from the base of the lamppost to the woman is x. We need variables for both of these distances, since they are changing. Define what we have and what we want then. We have the rate the woman walks from the lamppost. dx over dt is equals to 6. Now, the question is, we wanted to get the length of her shadow increasing. We want dy over dt, but if we want the rate of the tip of her shadow increasing, we want d times the quantity of x plus y over dt. That is because we need to measure the tip of the shadow in reference to the base of the lamppost. We also have the height of the woman, 5 feet, and we know that when the woman is 6 feet from the lamppost, or x is equals to 6, her shadow is 8 feet, or y is equals to 8. It turns out that we will need the height of the lamppost to get the equation we need to differentiate. So from similar triangles, we can get this. Next, determine what equation we need. We need to relate x and y to what we know, h and women's height, which we can do using similar triangles again. 8.75 over 5 is equal to x plus y over y, or simplified, 3.75y is equals to 5x. Now, differentiate with respect to time. 3.75 dy over dt is equals to 5 dx over dt. To solve for what we need, plug in 3.75 dy over dt is equals to 5 dx over dt. 5 dy over dt is equals to 5 times 6. Solving for this, making dy over dt is equal to 8 feet per second. This is the rate of the length of the shadow. To get the rate of the tip of the shadow, as earlier said, we need d times x plus y over dt, which is actually dx over dt plus dy over dt. So the rate of the tip of the shadow is 6 plus 8 is equals to 14 feet per second. As promised, we will give you an example of a complex function derivation. We will get the example from the product rule of the derivatives. Whereas the first derivation resulted to 18x squared plus 4. Getting the second derivation, we'll use the product of the first function, making it our second function. By using the power rule, we get 36x as the answer, or the product. Applying constant rule for our third derivation, we get 36. And lastly, 0 is the product for the fourth derivation.